afternoon, depending on when you're listening to this, maybe evening. This is Mrs. Robertson, and today we're going to go over our quarter one benchmark review number 1. Does this match? Is this the one that I gave to you on Friday? Does it match the problems? Okay, so let's look at these problems. Number 1, multiplication. The signs are alike. The answer is going to be positive. Now I'm going to go ahead and do my multiplication. 9 times 8 is 72. Positive 72. And I'm going to circle it. When I circle it, that means I've done all the things I needed to. Is my answer positive or negative? Did I do what I need to do? And when you circle it, that seals the deal. Number 2, the signs are alike. I'm dividing. The answer is going to be positive. Now, some of you I know can do that one in your head. Here I'm just going to show the work to make sure everyone knows how to do it. How many 4s live in an 11? 2. 2 times 4 is 8. Subtract, bring down. How many 4s live in a 32? 8. So the answer is a positive 28 and circle it. Any questions? Number 3, when you have it set up like this, you do the operation that's on top before you divide it by 2. The number on the bottom is what you're dividing by. So you have 87 minus 5 is going to be 82. So then you have a positive 82 over 2. That says divide, and it will give you the answer 41. Any questions? Number 4. Now, remember the rules of PEMDAS. Parentheses. Here, the parentheses are around the negative 21, so you know it's a negative 21. Exponents. Yes, I have an exponent. Then you do multiplication and division, or division multiplication, and the last thing you do is add and subtract, or subtract add. 6 to the second power is 36. So 36 minus a negative 21. Oh, add the opposite. Now they're both positive, and I'm going to add them. So my answer is going to be positive, and it's a positive 57. Any questions? Does everyone see how to read that one? Number 5. All right. I need to do my multiplication first. So I have 93 minus 4 times negative 8 is negative 32. Now, add the opposite. Man, this one is just way too friendly, because now I'm going to get another positive answer here, and the answer is going to be 125, I believe. Let me make this show up a little bit better so you can see add the opposite. Did everyone get 125? Okay. Positive 125. Negative times positive is going to be negative. It's negative 45. Any questions on 1 through 6? All right, let's go to number 7. Negative divided by negative is positive. Now, this is dangerous for you kids to do in your head, because you have to get your decimal point in the right spot or the answer will be wrong. So here, I have a decimal in the divisor. You move it 1. Move this one the same number of places, 1. Now, how many 3's in a 1? None. How many 3's are in an 18? 6. Subtract. Bring down. How many 3's live in a 6? 2. And the answer is a positive 62. Any questions? Number 8. Positive times negative is going to be negative. I'm going to put my negative sign down, and now I'm going to multiply. 7 and 9/10 times 6 and 8/10. I've already got my negative sign up there, so I won't forget to put it up in the answer. Here we go. 8 times 9 is 72. Put down a 2, carry a 7. 8 times 7 is 54, plus 7 is 63. Put a place value 0 down, because there's one number after the 6. 6 times 9 is 54. Put down a 4, carry a 5. 6 times 7 is 42, plus 5 is 47. Add the numbers together, How many numbers are behind the decimal point? 1, 2, 1, 2, and it's a negative 53 and 72 hundredths. Does everyone agree? All right. Number 9. That's a subtraction problem. I am going to add the opposite. Now the signs are alike, so I'm going to add and keep the sign, which means my answer will be negative. So I have negative 28 plus negative 19, and you're going to get a negative 47. Any questions? Number 10. I'm adding, the signs are different. I'm going to subtract. 86 is the bigger number. It's going to be a negative 32. If you had $54, you owe someone 86, you give them your 54, you still will owe them $32. Any questions? Number 11. This is all addition. Negative plus negative is negative. So that's a negative 14 plus a positive 6 is going to be a negative, what, 8? Negative 8. Any questions? Number 12. You're subtracting. Add the opposite. Now the signs are alike. You add and keep the sign. If you owe $8 and you owe 14, you're going to owe $22. Any questions? Fractions. When you have fractions and you have a mixed number, you have to change it to an improper fraction. You multiply, add, and put it on top. And before I go on, the signs are different. I'm dividing. My answer will be a negative number. So 7 times 3 is 21 plus 4 is 25. I have negative 25/7 divided by 5 over 21. Did everyone have negative 25/7? Look at your neighbor's paper to make sure they did this, because there were 3 people. When we did our test, they messed this up. They did not change them to improper fractions. So look at your neighbor's paper right now. Make sure they have negative 25/7 on their paper. All right. Now, keep, change, flip, or multiply by the reciprocal. Negative 25/7 times 21/5. Okay? That's negative 25. I wrote a 27. Oh, I can do my shortcut. Remember that? 5 goes into 5 once. 5 goes into 25 5 times. So that's a negative 5. 7 will go into 7 once. 7 goes into 21 3 times. Remember how to do the shortcut? It's a numerator to a denominator. Now, multiply straight across. Negative 5 times 3 is negative 15 over 1. The answer is negative 15. Any questions? That's the most missed problem on the test last year, was the dividing with mixed numbers, because they didn't change them to improper fractions. All right, here we have to find our common denominator between a 5 and an 8. It's going to be a 40. So we have to find equivalent fractions. 5 times 8 is 40. 8 times 3 is negative 24/40. 8 times 5 is 40. 7 times 5 is 35. Now the signs are different, so you're going to subtract. 35 minus 24 is going to be 11. And the answer is 11/40. Any questions? On this one, oh, it's the help, help. 9 has to change its name because we're subtracting, and 9 says, I will turn into 8 7/7. Do you know why it's 7/7? Yes.
It's because it's basically 7/7 is equivalent to 1.
That's right. And we're using 7/7 because the denominator of the fraction in the other number is 7. So 8 7/7 minus 5 4/7 gives you the answer of 3 3/7, and it's positive. Now, Here they want you to choose all that apply. They have some of these are simplified, some of them are not, but all of them they all equal the same value. All right, so you can do this. 4 times 15 is 60, and 5 times 24 is 120. All right, 60 and 120. Well, that's the same thing as a half. And 15 over 30 is a half, but 15 over 28 is not a half, okay? And you would have gotten a half by saying 5 goes into 5 once, 3 times, 4 goes into 4 once, 4 goes into 24 6 times, and you'd have 3 6, which simplifies to a half. But you need to circle all the ones that would equal a half. And there is a problem like that on your test. I don't think it's a half. But any questions on how to do that? Okay. Now, we're going to learn about rational and irrational numbers today, so I'm going to skip that for right now. We're going to skip this one because it's rational and irrational numbers. We're going to go down to the word problems. Okay? Lois opened a new bank account with $700. A couple of days later, she withdrew. Withdrew means you subtract. The next day, she made $30 tutoring and deposited. Deposit means you add. A day later, she used her debit card for $110 to buy new shoes. Debit card means you're going to subtract. Write an expression to represent Lois's bank transaction. Okay, you're going to have 700 minus 82 plus 30 minus 110. That's an expression. You don't have to put an equal sign. Yes. Yes, they will be. I just changed the numbers on the study guides. Yes.
It's okay if I have a different equation, which is $700 minus, in parentheses, 82 plus $110.
No, because 110 you're subtracting. You're using your debit card, so you're taking money out of your account. That's why I want to go over this, okay? Debit card is like a credit card. You're spending money, so that's a subtraction. When you see the word debit in your account, you're losing money out of your account, okay? So it's a subtract. What is Lois's new account balance? Well, 700 minus 82 will give you 628? No. 700 minus 82, 618 plus 30 is 648 minus 110 gives you a balance of, did you have $538? Good. Question.
I think Bryce's way would work because he was adding 110 plus 82, which was what you were minusing by, and then he was going to add.
Oh, but you have to do them in the order that they happen. So this is because of PEMDAS. If a subtraction sign comes before adding, you subtract. If you subtract 82, that's going to give you a different answer than if you added 82 and 30 and then subtract it, because you add the 30 after you subtract the 82. Those are the rules of PEMDAS, and the subtraction sign messes people up, okay? Now, let's do number 19. Micah's specialty bike is 7/8 of a yard tall. He put new wheels on the bike, which shortened it 2/9 of a yard. Shorten means we're going to subtract. He put air in the tires and it raised. We're going to add the height of the bike 1/8 of a yard. How tall is the bike now? Well, this is just sort of, nobody talks about their bike being yards tall. I think this is sort of a weird translation, but explain in words how to solve the problem. Show calculations using numbers and symbols to evaluate the real world situation. All right, well, let's just go first with the calculations. It's 7/8 minus, he put new wheels, which shortened it to minus 2/9 He put air in the tire and it raised it 1/8. All right. Explain words. First of all, you have to find a common denominator. Find common denominator because you are adding and subtracting fractions. I probably should have said you're subtracting and adding because we subtract first. You can use abbreviations. All right, my common denominator is going to be what? Does it have anything in common before a 72? I don't think so. So we're going to change them to 72. So that's where I'm going to put this in. You're going to have 63 over 72 minus 16 over 72 plus 9 over 72. Any questions? And then you're going to get 63 minus 16. That'll give you 47 over 72 plus 9 over 72. And you will end up having 56 over 72 yards. Any questions on that problem? Yes.
You can simplify your answer.
Yes. And what does it simplify to?
It simplifies to like 2/3.
2/3. Yes. You can divide them both by, well, you can start off with 2, and you're going to get 28 over 36, and then you can divide them both by 4, and you're going to get 7. Actually, I get 7/9 instead of 2/3. It simplifies to 7/9 of a yard. Okay, any questions? All right, now let's, you can go ahead and work on study guide number 2. And in just a moment, we'll go over how to do the rational and irrational ones after I go over the worksheet with you here in just a moment. All right, now we're going to talk about what rational and irrational numbers are. Today we defined and explored irrational numbers. An irrational number is a number that cannot be written in fractional form. We know a number is irrational if it is a decimal number that is infinitely long and has no repeating pattern. That means it divides on forever. Now, a repeating pattern for a division problem would be one where you had where the 2 repeats itself, or maybe you had an answer that it ends up like this, where the 7 and the 2, you could have 2 numbers repeat, or 3 numbers repeating. We're going to practice some long division problems later where that happens, but not today, I don't think. Here are some different ways of reading problems. We talked about this last week. The square root of 2, that's how you would read it. It is irrational. Why? 2 is not a perfect square. So if it's not a perfect square, it's irrational. The square root of 9 is rational. Why? Because the square root of 9 equals exactly 3. It has an answer. This is rational. The repeating decimal, it has a pattern. All right? You would write that answer as 0.01, where the 0 and the 1 repeat itself. Any questions? Now, this is considered irrational. Why? You're going to say, but Mrs. Robertson, it has a pattern, but it's not a pattern that you can draw a line over. I can't draw a line over something and say it's going to repeat like this. Yes, there's a pattern, but it's not a pattern where you can draw a line over it where it's going to be 2, 3, 2, 3, 2, 3, 2, 3. Here you just keep on adding another 0 in between the ones, and it gets longer and longer, and it will continue forever. Any questions on these examples? Okay, we learned that the square root of a number that when multiplied by itself equals the original number. Square roots include both positive and negative numbers. For example, the square root of 25 is plus or minus 5, because 5 squared equals 25 and negative 5 squared equals 25. However, if we write it as the square root of 25, then we are only talking about the positive square root. The only time you have to give the negative one is when there's a negative sign outside of the square root symbol, or if it's like this, then you give the negative. It says, provide 2 examples that show that the statement is false. Explain your thinking. Zoe said that an irrational number can be expressed as a terminating decimal. That is false. Why? Terminating decimals stop and they don't go on. So give 2 examples. There's an example of a terminating decimal. Remember, terminating means it stops. You could have 4.32. All right. Now, it says classify the numbers as rational or irrational. Pi is irrational. The square root of 110. Well, if you get your paper out that we worked on last week, you've got the square root table. 110 is not in the list. So 110 is irrational. All right. The square root of 81 is what, class? It's rational. It's 9. So it is rational. I'm just going to put rat for rational on that one. Rat, yes. Okay. The square root of 14. Does 14 have a square root? No, it's irrational. Negative 2/3 is rational. It can be written as a fraction. Now, find the square roots of each of these numbers. Well, the square root of 100 is what, class? And what's the square root of 49? Any questions? Okay, let's go to the next page. We're going to talk about Venn diagrams. Now, there are different types of numbers. When you were little bitty kids, you did the natural numbers. You started with 1. When you would count your numbers, you go 1, 2, 3, 4, and Grandma and Grandpa would say, can you count to 100? And you would show off and count to 100 or count by 5s or so on. Natural numbers they start with 1. The smallest natural number is 1. There are no fractions or decimals in natural numbers. Got it? Whole numbers has one more number. It's all the natural numbers, but it starts with 0. So you have 0, 1, 2, 3, dot, dot, dot. You know the dot, dot, dot means goes on forever. Integers are all of the numbers and their opposites, except 0 doesn't have an opposite. Do integers include fractions or decimals? No. Then we go to rational numbers. Rational numbers are the ones that include fractions and decimals. It says, simplify to make it less complicated, clearer, or easier. Do the math. So when you see the word simplify, usually it means to get the answer whenever you see it in the words. Sometimes they'll want you to simplify your fraction, that type of thing. Okay, now let's go to number 1. Let's simplify this so we know where it goes. Negative 10 over 2 is negative 5. That's going to go in which thing? It's going to go with integers. You're going to say, but it's a fraction. But it's a fraction that simplifies to negative 5. So put negative 10 over 2 in integers. Why? Because it equals negative 5. What's the square root of 36? Yes, 6. 6 is a natural number. So we're going to put the square root of 36 in natural numbers. 0 divided by 8 is 0. Where does this number go? In the whole numbers. The square root of 140 doesn't simplify. It's going to go into irrational, the square root of 140. 4/9. It won't simplify. Where's 4/9 going to go? Where do we put the fractions? Fractions live with the rational numbers. The square root of 4 is 2. 2 goes with natural numbers. -8 goes where? Integers. It's going to go in the integers. The square root of 8 is irrational. And -2.89. Where does -2.89 go? It goes with rational numbers. Any questions on how we did that? Okay, after a while, you're going to do 2 and 3 without my help. Yes.
What about 7?
Where's this? Oh, I forgot the 7. Thank you. 7 is a natural number. It goes with natural numbers. Okay, thank you for seeing that. Did I skip any others? Okay, let's go to the next page. Comparing real numbers. Now, this is what we're going to be doing, except on the number line, which is on the back of the paper is what we were doing on. And that's what you have to do on your benchmark test. You're going to have to put them on a number line. Don't think you'll have greater than and less than ones. Yes. What was that? I skipped -8. Oh, I did. I put it in integers. It is there. Thank you for being careful though. Yeah, -8 is in with the integers. Okay. All right. Numbers can be classified by identifying to which of the following sets they belong. We've done that. We know whole numbers. Check. They start with 0. Integers, positives and negatives with zeros. Rationals, numbers that can be expressed in the form of a over b, where a and b are integers and b does not equal 0. In other words, it can be fractions and decimals. Irrationals cannot be expressed in the form a over b, where a and b are integers and b does not equal 0. All right. Now, name all the sets of numbers to which these numbers belong. We know that, sometimes they want you to list all of the things it belongs to. 5, it's a whole number, it's an integer, and it's a rational number. 0.6 repeating. It can be written as the fraction 2/3. Decimals that terminate or stop or repeat is a rational number, so it's only a rational number. The negative square root of 25 is -5, so it's an integer. It's not a whole number, it's an integer because it's a negative one. And the square root 11 goes on and on, it's irrational number. It says to compare real numbers, write each number as a decimal that can compare the decimal values. As a decimal, and then compare the decimal values, okay? So here we're going to change them to decimals. To change a fraction to a decimal, you just divide the top number by the bottom number. 2 1/4 equals 2.25. I assume that you kids all know that 1/4 equals 0.25. What's the decimal for a half? Yes. Yeah. 0.5. 3/4 is 0.75. We'll talk about some of the others later on. Here you have the square root of 5 is approximately 2.23. Since 2.25 is greater than 2.23, 2 1/4 is greater than the square root of 5. It says name all the sets of the numbers in which each of these numbers belongs. Well, 30 belongs with whole numbers. I'm just going to use the first letter. It belongs to integers. It belongs with rational numbers. Okay? Now for rational, I'm going to put because real numbers is another group. It includes rational and irrational numbers. But, so I'll use rat instead of an R for that one. So on these, you'll just label them that way. Here you're going to compare with greater than or less than, but the ones I want to focus on are the ones where we put them on a number line. So let's go to the next page, and I'm going to do letter A. All right, we have to put these on the number line. These are all positive ones. 6 and 9/100. Is that going to be closer to the 6 or closer to the 7? Yes. Closer to the 6. It's 9/100 away from the 6. So put a dot close to the 6 and put 6.09. Okay. 35 over 7 equals 5. So put a dot on the 5 and put 35 over 7. When you do this on the benchmark, it's drag and drop. You're going to drop the dot onto the number line when you do it. The square root of 80. Well, you get your chart out. The square root of 64 is 8, and the square root of 81 is 9. So when you have the square root of 80, is that going to be closer to the 8 or closer to the 9? It's going to be really close to the 9. Nine over 2 equals 4.5. So that's going to go in between 4 and 5, and you put 9 over 2. And what's the square root of 16? 4. So put a dot on the 4 and put the square root of 16 over it. You do have to put the number above the dot on your worksheet. Are there any questions? Okay, now let's go back to study guide number 1 and finish the problems that we hadn't done before. And then I'll let you work on the other problems, maybe in groups today. We'll see. We've not had a group day for a long time. The square root of 9 is 3. 3, is it rational or irrational, kids? Rational. Put an R. Negative 0.5, is it rational or irrational? No, it's rational. Yes, it's a decimal that terminates, it stops, it doesn't go on forever. 8/3. 8 divided by 3. 3 will go into 8 2 times. Subtract, add a 0, bring it down. 3 goes into 26 times. Subtract. Oh, it's going to go on and on forever, but I can put a line over it. That equals 2 6/10 repeating. When you have a repeating decimal, is it rational or irrational? Yes, it's rational. Yeah, now if you couldn't draw a line over it, then it's the irrational one. But you can draw a line over it. Negative 1 5/7. Well, 5 divided by 7. 7 goes into that 7 times. 49, subtract, add a 0, bring it down. 7 goes into 10 once, subtract, add a 0, bring it down. We're going to that 4 times. 28, subtract, add a 0. It'll go into that 2 times. That's 16, subtract. I think this one goes on forever. Let me check with the calculator on this. If you have 5/7, yeah, it does not, there, can you see that a little bit better? Yeah, it does not repeat. It's irrational. It keeps on going and going, so it's an irrational. The square root of 3 is irrational. There's nothing that has an exact square root of 3. Any questions? One of the most popular irrational numbers is pi. If you ever see that, let's just put this on your paper. Pi is irrational. That's another one of those. Oh, it's a Greek letter, and on Friday we're celebrating Greeks and Romans, so maybe we'll talk about pi on our Greek and Roman day. All right?
We have to talk about it on Pi Day.
Yes, we will. Now let's go putting them in the right spot. On this one, let's make sure we have them in the right spot. The square root of 16 is 4. Put a dot on the 4 and put the letter A above it since it has a letter. Negative 1.5 is in between negative 1 and negative 2. Put your dot and the letter B. Kids, my technique for this is say it lives between these two numbers because sometimes kids will put it between negative 1 and 0 because they aren't careful. So just say that's between this one and this one. 12/5. That's going to be 2 and 2/5. All right, that's going to be about in the middle between 2 and 3, a little closer to the 2. Negative 2 and 1/6. It's going to be close to the negative 2, but you would have negative 3. It's going to be between negative 2 and negative 3, closer to the negative 2. And E, the square root of 8. Well, you know the square root of 4 is 2, and the square root of 9 is 3. Is it going to be closer to the 2 or closer to the 3? It's going to be closer to the 3. So put a dot there and put the letter E. Any questions? All right, so what are you going to do for classwork homework? You're going to finish doing study guide number 2. I gave it to you for bell work. And then you're going to do on this paper, you're going to do 2, 3, 4, and 5. All right, finish that up. Oh, and you can do letter 1B too. Do that one, the square root of 17. And I think, oh, and when you had the Venn diagrams, do 2 and 3. All right, and again, real numbers are rational numbers and irrational numbers. Later on when you're in high school, you'll learn about imaginary numbers. There's another group of numbers. We're not done with the numbers. They're called imaginary numbers, and you use them in calculus. All right. Okay, so that is it. Have a good day, and you can go work on your things. I'll let you know if we can work in partners in just a moment.